Hello guys, welcome to this tutorial. I'm David Okot. I'll be privileged to take through this drawing of SFD and BMD. And this is a special beam because it has a bending moment at end F. So the question is, you plot the shear force diagram at bending moment diagram. You calculate the point of contraflexion from the left hand. Now, this is how we shall proceed. Now, looking at this particular beam, you realize it has two supports, that is A and B. And as I told you earlier, you can only take any of a support as a reference for you to determine the reactions. And also you should know that at point A, at support A, I have reaction A, and at support B, I have a reaction B. Now, this is what shall proceed. We will now determine the value of reactions RA and RB by taking moments about support A. When we take moments about support A, one thing we know is that the sum of moments about point A is 0. And as I told you earlier, I will assume at A I have a hinge. Now B doesn't exist in that case. And try to imagine this force of 5 kilonewton, in which direction will it cause this beam to rotate? This 5 kilonewton per meter will try to make the beam rotate in anti-clockwise direction. The UDL of 10 kilonewton per meter, remember hinge is at A, it will make the beam rotate in clockwise manner. Then RB is acting upward, which means it will make the beam rotate in anti-clockwise manner. And then this 40 kilonewton meter moment, from each direction from the arrow, it means it is making the beam rotate in anti-clockwise manner. Now, this will imply that we shall add together moment which support each other, and then we equate to the moment which tend to act in the opposite direction. Now, we can proceed and take like the moments which make the beam rotate in anti-clockwise. We shall start with them. We have this UDL of 5 kilonewton per meter. Now remember, reference point is A. I will take 5 times 2 to convert it to point load, and it is acting midway of CA, which is 5 times 2 point load, then times 1, which is distance from point A, plus 40. Remember this 40 kilonewton meter, you cannot multiply it by anything because it is already a moment. So we shall use it the way it is. Don't multiply, use it the way it is because it's already a moment. Then plus RB, reaction at B here, its distance from A will be 2.5 plus 3, which is 5.5 plus 2.5, which is 8. We equate to, now the only moment that is causing the beam to rotate in clockwise direction is 10 times 3 into a point load will be 30. And then now this 30 is acting midway of DE, which is 1.5 from B. So the total distance from A will be 2.5 plus 1.5, which is 4. If I make RB the subject, I will take 70 over 8. I get it as 8.75 kilonewtons. But we know that the sum of upward forces, those are reactions, is equivalent to the sum of downward forces, which are the applied forces. So, and then another thing, you should know that when adding the sum of upward forces or downward forces, we don't include a moment. A moment is not part. So this 40, we shall not use it here, but rather we shall say RA plus RB is equivalent to 5 times 2 to convert this UDL into point load plus 10 times 3 to convert the second UDL to point load. So this will give us RA is equivalent to 31.25 kilonewton. Now for us to draw the shear force diagram, we shall draw line CF. As I said earlier, CF will act as our x-axis or the 0 line. And then on my left, I will indicate SFD. kilonewton, which means the unit that will be there is kilonewton. And then plus, this plus means whatever I plot on the upper side of line CF is positive, whatever I plot on the lower side of line CF is negative. So I will start by saying shear force at C is 0. Here I have it here, 0. And then shear force now from C to A, we have a UDL of 5 spanning over 2. So we shall take 5 times 2. Since it's acting downward, it will be a negative, so it will be negative 10. That's why we have here negative 10, but I didn't indicate because it automatically shows it is below the line CF, so it is negative 10. And then when I arrive at A I have a reaction of 31.25. Since this reaction is acting upward, it is plus. So it will be minus 10 plus 31.25, which will be positive 21.25. Looking at it, you see it is on the upper side of the zero line, meaning it's a positive. Between A and D, there is no force, so it will be a straight horizontal line. At D, between D and E, there is a UDL, so it is arriving here as 21.15, and between D and A we have a UDL of 10 kilonewton per meter times 3 meter, that is a negative 30 because it is acting downward. So it is 21.25 minus 30. So that will end to negative 8.75, but it's not negative because I didn't indicate because it is below the line CF, so which means automatically is negative 8.75. Between E and B, there is no force, so it will maintain 8.75 up to B. When it arrives at B, I have an RB of 8.75. Now, because this is negative 8.75, RB is acting upwards, positive, so minus 8.75 plus 8.75 goes back to 0. So the diagram will end at B. I told you we don't use this 40 because it is a bending moment. And then now from there, let us proceed and go to how to draw a bending moment diagram. Moment at C is 0. Now in this case, we shall use the area method, the area under SFD method. Now the moment at A will be, now look at A, moment at A here, it will be the area under SFD. Now remember our reference line is CF. So this area is lying on the lower side, meaning it is a negative. That's why I start with negative. Now it's a triangle, negative a half times 10 times 2. 10 is the value of shear force, and then 2 is the distance between CA. You get it is a minus 10 kilonewton meter. Then moment at D, look at D. D is here. Now when we are calculating the area, reference will be on the shear force diagram. So between A and D, we have an area on the upper side of line CF, so which means in positive. So we'll take rectangle, we'll take 2.5 times 21.25. So it is moment at A, which is minus 10 plus the area, 21.25 times 2.5. I'll get 43.125. Then I have a point of interest, that is a point between D and E in which the shear force diagram line is crossing the zero line, because this implies this is where I have the maximum bending moment. So I will determine it, and as I said in the earlier tutorial, if I want to determine the value of this X here, I will equate the sum of shear force to 0 at this point. Now look at our left-hand side of X. To the point X, we have a UDL of 5 kilonewton per meter. We multiply it by 2 to make it 10 point load, but it's a negative. Then I have RA, which is acting upward of 31.25, so it is a positive. And then we have a section of that to 10 kilonewton per meter, which is acting downward. So I can say minus 10 times x, the unknown value. Now that x, I can assume it is a measure from line D, not point D, to where the SFD line crosses line CF. So I will come and say minus 5 times 2, minus 5, this is UDL, is acting downwards, and a minus, plus 35, reaction A is acting upward, minus 10x. 10x is converting this UDL to point load by multiplying by an unknown measure x from D to point where it is intersecting is equivalent to 0. So you find that x, it will be 2.125 from D. So from D, x is 2.125. Now it will mean if I want to compute the value of moment at x, it will be so easy. It will be equivalent to the moment I had at point D plus area plus that area, because the area is on the upper side of CF, so it is a positive, plus a half times 2.125, the distance you've calculated, multiplied by 21.25. Remember, 21.25 is the value of the shear force line. So I will get the value will be 65.7 kilo Newton meter. Then moment at E will be moment at X. Now see, for E, it is below. So it will be moment at E minus the area of this small triangle, because the triangle is lying below CF. I will proceed and say 65.7 minus a half times 8.75. Remember, 8.75 is here, the value of shear force. And then this distance, 0.875, this is how we get it. From D to E is 3 meter, but D to X, we got it is 2.125, meaning the remaining from X to E is basically 3 minus 2.125, so it's 0.875, so it will be 1.87 kilonewton meter. Then moment at B will be equivalent to moment at E, which is 61.87 minus. Now, the reason we are subtracting is because from E to B, the area is below line CF, and it is 8.75 multiplied by 2.5, which is the distance. Then we get approximately 40 kilonewton meter. Then moment at F will be 40. Now, since this other 40 at F is acting in anti-clockwise manner, it is negative. So we subtract 40 and we get moment at F will be 0 kilonewton meter. And now what I want to tell you, then now we can plot, but there is a mistake from C to A, because shear force is linearly varying. Please draw a smooth curve from C to A. Don't use a straight line. This is a mistake, but use a smooth curve, because since the shear force is linearly varying, the bending moment should be a smooth curve. I think that is okay. And then we want to determine the point of contraflexion. They told us from the left end, point of contraflexion only occurs on the bending moment diagram, not shear force. So after you plot the bending moment diagram, the point where your sketches, the plot will cross that line. For example, our case line CF, that is the point of contraflexion. And what you need to know is that at point of contraflexion, the sum of bending moment is equivalent to 0. Now, assuming I call it x1, so which means this x1, I can assume the distance from A to that x1, I give it a value x1. So now take moments on the left of that x1. I have how many forces? I have 2. I have a UDL of 5 kilonewton per meter, and I have a reaction RA. So we'll proceed and say, and you know, a UDL will give a negative moment because it is a negative force acting downward. I will take negative 5 times 2 to convert it to a point load. Now, this point load is acting at mid of CA, which means it's acting at 1 meter. So we have that 1 meter to A, and then plus x1 units to this point here. That's why I have 1 plus x1 plus reaction at A is 31.25, but is acting x1 unit from the point of contraflexion. This is what we have here. We equate to 0 because at this point, the value of bending moment is 0. So from there now, we will come and say the only unknown is x1. So from there, you can solve for x1 and find x1 is 0.47 meter. But remember, 0.47 meter is just from point A to where the line is crossing the neutral line. But if I want to compute the value of contraflexure from the left-hand side, I will take, it will be CA, which is 2 meter, plus that 0.47, which is equivalent to 2.47 meter from the left end of the beam. I hope you've enjoyed this lecture. See you in the next. Goodbye. Subscribe, like, and share my channel.